Hello, my name is Mason Tan. This is the long 15-minute YouTube video of my final project topic, the Amazon Elastic Transcoder. This final project is for my CSCI e90 cloud computing course taught by Professor Zoran in the Harvard Extension School. If you haven't seen the short 2-minute YouTube video, please check it out. In this video, I will go into detail the Amazon Elastic Transcoder and my final project. So what is the Amazon Elastic Transcoder? It is a service that transcodes media files in the cloud. This is Amazon's solution for developers and businesses to effectively transcode media files from their source format into different versions that will play back on different devices, such as smartphones, tablets, and PCs. So what are some of the benefits and drawbacks for using the Amazon Elastic Transcoder? Some of the highlights is that it is elastically scalable, meaning it can handle large volumes of media files and large file sizes. You can perform multiple transcodes in parallel. It is easy to use and is cost effective. You pay based on the length of the output in minutes of the media you are transcoding. The service takes care of scaling and operating the system so that it does not require you to manage transcoding software in a distributed cloud-based environment. It also has support for many common output formats, and you can always customize your own settings if needed. However, as of now, there isn't a comprehensive list of input formats. Amazon states that they support popular web, consumer, and professional media formats such as 3GP, AAC, AVI, FLV, MP4, and MPEG-2, and that they add new import formats on an ongoing basis, so such a list would age quickly. So you would have to try and see whether your source media file will work or not. There is also a limit on the number of pipelines, jobs, and presets. As of now, the limit is 4 pipelines per AWS account for each region, 100,000 jobs per pipeline, 30 outputs per job, 50 user-defined presets per AWS account, and others, such as the maximum number of jobs processed simultaneously by each pipeline and the maximum rate at which you can submit job requests. So if you want a higher limit, you would have to contact Amazon first. So let's go through the Elastic Transcoder process. First, you upload your media files that you want to transcode into an Amazon S3 bucket. Then you create a job which transcodes your media files based on the presets you select. You can choose to transcode your files to different output formats. The Elastic Transcoder will queue the job in a pipeline. When the job is finished, the transcoded media files are uploaded into an Amazon S3 bucket, where they can be played back with different devices, based on the presets you selected when creating a job. And this is the process of the Amazon Elastic Transcoder. This is just my simplified overview of it. It may become a little more complex as you add more Amazon S3 buckets, pipelines, jobs, and presets into the picture, but hopefully the idea is clear. So let's go into a bit more detail on the different parts of the Elastic Transcoder. The Elastic Transcoder is mainly made up of 4 different parts. The first part is the job. A job does the work of transcoding. Each job can convert one file into 30 formats or less. So if you want to convert a media file into 12 different formats, a single job can accomplish this. You have to specify the name of the file to transcode and the names of the transcoded files. You also have to specify a pipeline for a job and a preset for each format that you want to transcode into, both of which I will go into in a bit. The second part of the elastic transcoder is the pipeline. A pipeline is a queue that manages transcoding jobs. When creating a job, you have to specify a pipeline to add the job into. The jobs are processed in a pipeline in the order in which they are added. But if a pipeline already contains jobs when a new one is created, then the newest job is queued and begins processing as soon as resources are available in the pipeline. If there are no resources available, then you would have to wait until one of the jobs is finished processing. It is important to note that a pipeline can process more than one job simultaneously, and the time required to complete a job depends on the size of the file to transcode and job specifications. Thus, jobs don't necessarily complete in the order in which you create them. Another thing to note is that you can pause the pipeline to stop processing jobs temporarily. The third part of the elastic transcoder is the preset. A preset is a template that contains most of the settings for transcoding media files from one format to another. The elastic transcoder already has some default presets for common formats that you can choose. If there is a preset that isn't included in the default list, then you can create your own. And the fourth and last part of the elastic transcoder is the notification. You can configure the elastic transcoder and Amazon Simple Notification Service, aka SNS, to keep you informed of the status of a job. Therefore, you can know when the elastic transcoder starts processing a job, finish a job, and whether it encountered a warning or error during processing. With notifications, you don't have to poll to determine when a job has finished. You can configure notifications when creating a pipeline. Now that you have familiarized yourself with the Amazon Elastic Transcoder, I will go over my final project. This project will go over most of the process that I have talked about in this video using the AWS SDK for Java. This project is done using the latest version of Eclipse at this time, Eclipse Mars 4.5.1. My project consists of two parts, a bucket pipeline setup program and a job index setup program. The bucket pipeline setup program will set up the buckets and pipeline, whereas the job index setup program will set up the job and the HTML files. The HTML files will be used to host a website, which includes a video that has been transcoded by the elastic transcoder. First, I will go over the bucket pipeline setup program. This program has three main parts. The first part creates two Amazon S3 buckets, an input bucket for the media file to transcode, and an output bucket for the transcoded media file. When creating these buckets, I added an additional check to see whether these buckets already exist in my AWS account. If they do, then simply continue using the buckets. If not, then create them. It is important to note that the bucket namespace is global, meaning that the buckets will not be created if they already exist in someone else's AWS account. The second part of the program lists all the buckets in my AWS account and upload a video to transcode into the input bucket. Note that for this program, I placed the video file in the project directory of the Eclipse workspace where my project resides. The third part of the program creates a pipeline. Here it takes the input bucket name, output bucket name, pipeline name, and role. For role, I just use the default Elastic Transcoder role. Then it lists the pipeline and all of its info. Here, the pipeline ID should be displayed. This will be needed for the second program, Job Index Setup, which I will go over right now. Like Bucket Pipeline Setup, the Job Index Setup program also has three main parts. The first part creates a job. Note that creating the job will require the pipeline ID that was mentioned in the previous slide. First, the program sets up a job input, which requires the name of the video file to transcode. It then sets up a job output, which requires the name of the transcoded video file and a preset ID. Each preset has a preset ID, which you can find in the presets section of the Elastic Transcoder in the AWS Management Console. Then it creates the job using the pipeline ID, job input, and job output. It also lists the job that was created and all its info. Once the job is finished, the transcoded video will be uploaded into the output bucket that was created from the first program. The second part of the program creates an index.html file which will be used for website hosting. This index.html will contain the video that was transcoded from the job mentioned in the previous slide. The file will then be uploaded to the output bucket. The third part of the program creates an error.html file, which will also be used for website hosting. This error.html will simply redirect to index.html. The file will then be uploaded to the output bucket as well. Here is an example of what the console terminal output looks like when running the programs in Eclipse. In Bucket Pipeline Setup, the input bucket, ETS input bucket, and output bucket, ETS output bucket, are created. A list of buckets is displayed, showing the buckets that were just created. Then it uploads a video called Congrats into the input bucket. Congrats is just a short webm that I placed in my project directory. Lastly, it creates a pipeline called MyPipeline and displays the pipeline info, including the pipeline ID needed for Job Index Setup. In Job Index Setup, a job is created using the pipeline ID from earlier. The index.html and error.html files are also created and uploaded into the output bucket. Now to host a website containing the content of the output bucket. In a web browser, go to Amazon S3 and to the output bucket. It should contain three files: index.html, error.html, and the transcoded video if the job is finished. If the job is not finished, then please wait for it. Go to the bucket properties and check Enable Website Hosting. Then enter index.html and error.html in the index document and error document fields, respectively. Select Save and check the website by entering the endpoint URL in a web browser. If there is an error in viewing the website, make sure to grant the right permissions for the three files. And here is the website that contains the video transcoded by the Elastic Transcoder. This concludes my final project on the Amazon Elastic Transcoder. Thank you for watching.